We've been watching tortoise populations for the desert tortoise for a little over 30 years in the desert, almost 40 years in some areas, and everything indicates to us that there's been a steady decline in populations over that time. And until recently, it was kind of a mystery. We knew that it was lots of influences, but only recently have we had the ability to get on the ground and collect massive amounts of information across the entire Mojave Desert and then put it all into analyses that we can start to understand the pattern for the Mojave. And we're starting to pin down pieces of that story about why are we having these declines.
And then, did you say number 2 is the one without the transmitter?
82859.
Over the last 5 years, we've been working with a team of scientists, including biologists, but also ecologists, plant ecologists, people who do GIS, remote sensing, hydrologists, geologists, and geographers to put together a desert tortoise habitat model. So looking at different elevations, different rock types, different vegetation associations, different precipitation and temperature regimes, and how those all come together to influence what we know as the current desert tortoise distribution.
Shades from yellow to orange, then red, show good to ideal tortoise habitat, while dark blue is not tortoise habitat.
So here in the Mojave Preserve, we can see we have areas of high tortoise concentration and predicted high suitable habitat, and also areas like these blue ones where we predict that would be low suitable habitat.
The model's ability to predict habitat type is proving to have wide applications across the Mojave and into the future. It's an invaluable tool for guiding the search for best locations to site new green energy projects. And the model can project us into the future, helping to clarify possible impacts of climate change. Model components such as rainfall totals and temperature can be adjusted to show how habitats will shift as the climate changes. The model helps scientists understand the desert tortoise on a range-wide scale over millions of acres. It has the potential to make a huge difference in desert tortoise recovery, helping to ensure that critical habitats will be suitable into the future. There's no one thing killing off desert tortoises. A multitude of threats are interacting. Scientists must prioritize which are the most important and which problems can be solved. Hey, baby tortoise, the heat is on. Not only do you have all the struggles of life in the harsh desert and dwindling habitat, now there are new threats on the horizon.
I think in prehistory, pre-Western history of people moving out here, this was a giant wilderness. It was a very hostile environment to humans. And about just a little over 100 years ago, the West began to be opened up with new trails for immigrants. Those folks were sort of eking out a living in the low desert areas. Then the highway system was put in that opened up the area so people were moving through, and widespread availability of lots of electricity and air conditioning made it a less hostile place. And what this all leads to is going from an area that was just little islands of human habitat 80 years ago and 60 years ago to what is now becoming an area that is dominated by human influence with little tiny islands of open natural habitat left. And that's where we still find the tortoises, is in these little islands that are left.
Not only has development encroached into the desert, scientists have recently found a pattern that shows human impacts extending beyond where people are living. There's a shadow that's much larger than the actual footprint of buildings and roadways. It's created by predators, such as coyotes and ravens, that are subsidized by human food and waste. Living outside the edge of these areas, others have their eye on the desert too.
There's a lot of sunshine in the Mojave Desert, and there's a lot of open land that energy developers and people who are really interested in getting the country off of fossil fuels look at and say, wow, look at all that sun hitting the ground and we can put solar fields there. Well, that's where the desert tortoise lives and other sensitive species.
I think it's important that you put these solar projects and the windmill projects over at the edge of the desert, the western edge, or maybe the eastern edge, or near major cities, but not in the middle. Then you're bringing an industrial park into the middle of tortoise habitat, so siting of the energy projects is crucial. The first priority being to put them on lands already disturbed or where there is no tortoise habitat, and the second being not to fragment large areas that are a uniform block of habitat.
The challenge is finding the right balance to be able to achieve our alternative energy goals while not sacrificing the native landscape and our natural heritage at the same time.
One definition of desert is a landscape that gets less than 10 inches of rainfall a year.
When the desert gets a good year, maybe 1 in 10 years, we'll have a really good winter rainfall. And in those years, it's just unbelievably spectacular.
In the Mojave and Sonoran deserts, there live nearly 150 species of mammals, including mountain lions, ground squirrels, and desert bighorn sheep, along with 70 species of amphibians and reptiles, and more than 300 species of flowering trees, shrubs, and wildflowers.